Hi everyone and welcome to the introductory tutorial of the Volumetric Nebula plugin now available in the Fab Marketplace. In this video, we will walk through how the plugin works, break down the core systems behind the volumetric effects and help you understand how everything from noise generation to remarching comes together to create rich dynamic nebula visuals. So let's get started. The primary actor that you're seeing in this level is a blueprint actor derived from the volumetric actor base class. This actor forms the foundation of all volumetric nebula that you create, ensuring consistent setup and optimized performance. Before we start creating our own nebula from scratch, let's first take a closer look at how the system works. We will explore the various properties and components of this actor that come together seamlessly to shape the nebula you're currently seeing. Here you can see this render target material, which is responsible for generating the visuals that are drawn into the volume render target. This render target acts like a pseudo volumetric texture, capturing layered procedural noise. And the render target material is where you can blend and combine multiple such procedural noise textures to create complex volumetric patterns. The output of this material is written into the volume render target, which is then used by a separate density remarching material for sampling and rendering the final volumetric effect. So an instance of this density remarching material is applied to the static mesh component inside this volumetric actor. Here you can see I have enabled draw real time, which allows me to see updates live in the editor as I modify the render target material or related parameters. However, this option is turned off during gameplay by default, and I also recommend disabling it when you are not actively making changes. This helps maintain better performance. Now in the noise texture map section, this is where we assign our noise data assets. It's an array where each element consists of texture name, which is a string identifier that corresponds to the parameter name used in your render target material. Then we have target noise texture, again a pseudo volume texture where the noise will be written. And finally we have the noise data asset. This defines the type and behavior of the noise itself. Currently, the system supports various noise types such as Perlin-Verley, Musgrave, and Simplex. I will be adding more noise types in the future, and we will go into detail about how to create and customize this when we build the system from scratch in a separate video. Alright, so let's now start adjusting the noise parameters. As you can see, the volume updates instantly thanks to draw real time being enabled because the changes are being written directly to the associate noise render targets. You can find detailed explanations of all these parameters for each noise type in the documentation. However, the basic structure of every noise dataset follows a consistent layout. First, we have the noise specific properties at the top section. These are unique to the selected noise type. For example, in this case of Musgrave noise, you see the noise type. Then we have dimension, noise offset and gain, and also turbulence and belay properties. So these properties will define the base structure of the shape specific to Musgrave noise. Then we have the core noise properties common to most multi-octave noise systems such as frequency, amplitude, roughness, etc. You also have additional noise layering through the multi-scale frequency multipliers available here. You can use the seed parameters to randomize the shape. You can further fine-tune the shape using contrast and remap adjustments over here. Here you will see the advection controls which handle flow-based attributes like turbulence, vorticity and directional motion. These are especially useful if you are going for dynamic effects. But currently we are not creating any animated cloud effects as none of these parameters are being updated over time. This plugin has been developed with performance as the top priority, so I have intentionally kept things static for now. That said, there is still a lot of experimentation and optimization to be done before we move forward with the real-time animated effects. However, the advection controls are already in place with that future goal in mind. The idea is to eventually use these settings to drive dynamic motion, allowing clouds and nebula to evolve naturally in real time. Now let's open this other noise data asset and start making some modification. So you can tweak both of these data assets independently and observe the changes in real time. As we discussed earlier, the render texture material is taking the output from both of these noise layers and combining them to create the final volumetric texture. Let me show this to you once. So this is the render texture material instance. Let's open the parent material. Here you can see that I am using the two noise textures generated from the corresponding noise datasets. So the texture parameter names used in this material should match the names defined in the noise texture map over here. And that's how the system knows which texture to update in real time. You can easily create your own render texture material and blend any number of noise textures using the preferred method. For example, here I am using the blend screen node to combine these two noise textures, both for the color and for the density, which is taken from the alpha channel. And then I'm applying a color dodge to enhance the highlights and then finish with an HSV adjustment for the final color tuning. So this material output is then written to the final volume texture, which is later used by our main remarching material. We will look into that in just a moment. Before that, let's open the render texture material instance. So here you can adjust the parameters to further colorize your volume as well as controlling the density of the individual noise textures. Alright, so the final layer of customization comes from adjusting this volumetric material instance over here. So here you will see a lot of parameters to choose from that are directly related to density remarching properties of this material. First, you have the ambient color to control the overall color tone of the ambience of this volume. The light color is the color of the area directly affected by the directional light you have in a scene. And you can further adjust your color via gamma correction and contrast boost. Then we have the density parameters over here, which directly affect how thick or transparent the volume appears. Adjusting these values let you enhance or soften the overall density of the nebula. The density threshold you see over here is going to clip the low density region. It works in combination with this threshold width parameter to create a smooth fade or a sharp cutoff for areas below the threshold. The edge fade mean and edge fade max parameters control how the emission fades out toward the edges of the volume. And here you can adjust the emission properties which control how much glow or internal light your volume emits. You can combine this with the light, color and ambient color settings to create truly stunning and dynamic color effects in your volume. Next we have the absorption parameters which control how light is absorbed as it travels through the volume. The absorption coefficient and absorption falloff parameters defines the overall strength of the light absorption. So the volume reacts dynamically to directional light. And the anisotropy influences how light scatters within the volume. When it is closer to 1, it gives this dark patch where the sunlight is supposed to be. Ideally, it should be something significantly lesser than 1 so that the light can spread out evenly. And the distance attenuation scales how absorption is increased as you move away from the volume center. Now let us continue customizing the parameters till we get satisfactory result. Now anytime when you want to change the noise shape, you can go back to the respective data assets and continue your customizations. Now let's talk a bit about performance, something I have prioritized heavily while designing this system. The plugin is already highly performant because the procedural noise is baked into pseudo-volumetric textures ahead of time. This means that the system doesn't need to compute expensive noise functions during rendering. Instead, it simply samples the pre-generated textures, which is much faster. The main performance consideration now lies in the density remarching material, where I have introduced this max steps parameter. This controls how many samples are taken along the ray as it moves through the volume. Fewer steps means faster performance, but at the cost of visual quality. As you can see, I am getting a lot of artifacts and banding with lower max steps. On the other hand, more steps improve detail and smoothness but can lower your frame rate. So I have found that a step count between 130 to 200 offers a good balance between visual fidelity and high FPS, especially for real-time environments. You can notice how increasing the max steps further is marginally improving the quality but at the cost of reduced frame rate. So you need to find out the balance, and I'm still definitely constantly trying to improve the visual quality as well as further enhancing the performance. Alright, so that wraps up our today's tutorial on the Volumetric Nebula plugin. We explored how the render target material blends multiple noise layers, how data assets drive procedural shapes, and how lighting, emission, and absorption parameters all come together to bring the volume to life. So in one of the upcoming tutorials, we will start building our own nebula system from scratch so you can create completely customized volumetric effects suitable for your project. Check out the full plugin documentation for more in-depth info. If you face any issues with the plugin, you can get the link to the Discord server in the Fab Marketplace description page. So join the Discord server to directly communicate with me regarding any bug fixes, feature requests, or any other inquiries that you have related to this plugin. I am very happy to help you out. Thanks for watching, and I will see you in the next video.